Good morning, everyone. I hope you can all hear me, right? So, um, okay. Actually, I am a bit nervous because you are all teachers, educators, and I am standing before you, and I want to share certain things about my student days. In my student days, we had a particular period called moral science period. I believe you all would have had that period. That period was specially designed for us to finish our homeworks that we haven't finished at home, right? So this is an important aspect for us to understand that we have a moral science period. That moral science period, the people who designed the moral science period, they would have thought that this period would be used to inculcate morality to the students. But the teachers who taught, they never saw any utility in that. They would allow us to do whatever we wanted to do. Because they know that these moral values would be taught in the houses itself, families itself. You don't have to go and teach them don't lie, don't steal, be good to others. All these, it would have been taught in their houses. So why do we repeat these things? So let the students have some free time if they are having some things to finish, if they have a homework to finish, if they have a answer to memorize, let them do it in this particular time. So they would allow it. So it was like a free period. We have to understand that this particular fate should not fall on Indian knowledge systems. It should not be just another module. The students are taking so that it is easy credit. Students are taking because it is jolly good time. Okay. So what we have to do is, we have to make sure that the Indian knowledge system that we are teaching is relevant to the student in the particular knowledge domain that he or she is going to enter. How do we do it? We are in an unenviable position. We have to teach them lessons. We have to teach them the lessons in such a way that they learn science as a unified body of knowledge. Technology as a unified body of knowledge. And they have to prepare for their exams, their objective-oriented question answer sessions, multiple choice question answers. In all this, is Indian knowledge system going to help them? It is very questionable. The present educational system of science, in that to secure marks, to understand the subject, is Indian knowledge system going to help? If you are going to honestly answer this question, the answer would be most probably in the negative. This is something that we have to ponder over and we have to change. So when I was preparing for this particular session, fortunately, I was given by the Swarajya magazine a particular book for review. This book was written by a person called Guido Tonelli. He was a physicist from Italy, and he was one of the discoverers of Higgs boson. He had written about the formation of the universe, the nature of matter. Okay. So he started with this very interesting etymological relation, the relation between the words matter and matter. And then he said that for the ancient Greeks, the matter and matter, they had the same etymology because they didn't see matter as a kind of a passive thing. They saw matter as a kind of a creative matrix from which things emerged. So he started with this etymology. He went into how the theory of atoms came in the Greek tradition and everything, how the modern scientific method evolved. He explained all that. And then he went to the cutting edge cosmology. And he finished with this very interesting view. He said that now we understand what we call matter is nothing. So that is why he named the book as Matter, the Magnificent Illusion. He said that there is no such thing as matter. And he said that what we call Big Bang is actually a vacuum becoming another vacuum. A spectacular transformation of one vacuum becoming another vacuum. Now, how do we understand this? He started with the Greek etymology. He went into certain pagan traditions. And then he went into the modern science and he taught. He ends with this. This is a popular science book. A book that conveys to the reader what is happening in cosmology. And to conceptually understand this particular aspect, that Big Bang is actually nothing but one vacuum becoming another vacuum. And what we call matter are small geometric distortions in a flat universe. To understand this, what kind of conceptual tools I need? Now, if you are familiar with Advaita Vedanta, it is very easy for us to understand this. Then we say that yes, this is Maya. And Maya is not illusion, it is a creative illusion. And this creative illusion is created because through knowledge you can obtain liberation. And how do you then differentiate between this vacuum and the reality that we are seeing around? We have two layers of reality. One is the Vyavakarika and another one is the Paramarthika. And they are not compartments, there are small threads that connect them. And these threads are the threads of cognition and jnana. And so you have, when you read this book, he doesn't mention all this, but when you are reading this book, all these things will come to you naturally, spontaneously. Why I am saying this is because this popular science writing is something that every teacher of science, every educator of science has to study. And then you will understand why Indian knowledge system is important. It is not a separate module. We have to understand that very clearly. An Indian knowledge system is not a separate module. You may be teaching that as a separate module, don't worry about that. But when you are teaching your subject, make sure that what are all the intervention points in which you can talk about Indian knowledge system. You can give the child, you can give the student a framework for Indian knowledge system. That's what? When I tell about this particular thing, about giving a framework, I have to emphasize three things. The first thing is you have to give them a sense of wonder. That is very important. There was this famous, again, a popular science writer. His name is Lewis Thomas. So Lewis Thomas wrote about teaching biology. And he writes this. I am telling from memory, but a few words can change here and there. He says, when you are teaching biology, don't teach the utility of biology. Don't teach that biology is a profitable science. Teach them the wonder. Teach them that inside your cells are a lot of small structures that are producing energy which could have come from bacteria. How it entered into your cell and became part of your cell, we do not know. But this has happened billions of years ago. This kind of symbiotic relations have evolved billions of years ago. You can teach oxidative phosphorylation or photosynthesis later. But first you teach this wonder. The child should feel that inside its body, inside every cell of its body, there is wonder that is happening. Teach them ecology. Teach them that you are part of a gigantic organism which is consisting of a lot of independent, interdependent connections. This sense of wonder you have to teach the child. And if you are teaching this child this sense of wonder, then the child will become an inquisitive child. It will search for answers. It will not settle for the answers. It will generate questions. That is what science is all about. That is what real education is all about. The real education is not providing you answers. The real education makes you ask questions and move forward. And for that purpose, you have to infuse them with a sense of wonder. That is number one. Number two and number three are two important fallacies that can happen when you are teaching Indian knowledge system. The first fallacy is, we know them all already. Never give the child this idea that we know it all already. The second fallacy is we were the first to discover. Don't give the child the idea that we were the first to discover everything. We don't have to be the persons who climbed each and every technological and scientific peak. A lot of people have done a lot of things. Then what is Indian knowledge system about actually? Indian knowledge system is about giving them the tools for knowledge. You are actually opening window. Okay. Through this window, the child, the student can look outside the universe. The difference between Indian knowledge system and the other knowledge systems is that there is only one window in other knowledge system. And it has created a lot of problem. The Aristotelian window. If you are talking about the Western knowledge system, there is only the Aristotelian window. You can only go see through that particular window. And when you started looking through that particular window and when you started seeing things that doesn't fit into the shape of that window, a lot of problems started happening. They wanted to break that window. In the case of India, you have 6 windows, the 6 darshanas, through which you can approach the reality in different ways. And when you approach the reality in these kind of different ways, then you will have different kind of questions. What do I mean by this? Let us consider the question of how a particular organism's particular organ functions. Okay, eye of a particular insect. How does it function? It's a compound eye. How does it function? When you are going and studying that particular aspect, you can have a framework. What is that framework? For example, if you are believing in what is called natural theology, okay, you believe in what is called natural theology. Natural theology is the dominant knowledge tool that was available in 18th, 19th century Europe. It said that God has created everything. When you understand a particular organism's organ, when you understand how a leaf functions, when you understand how the hand functions, what you are actually understanding is how God has put these things together. You are understanding the mechanism through which God has created this. So, why you have to do biology? Because you want to understand how the organisms have been designed by God. God is this great designer. Okay. So in 1859 a book got published. So this particular book said that there was no design. Things have evolved from a small, tiny, single cell organism perhaps, and through all the laws of gravity as well as the other physical laws and the different circumstances, through natural selection, the process of natural selection, all the diversity that you are seeing around you that have come up. So this is the book Origin of Species by Charles Darwin. Thomas Huxley famously said that Charles Darwin has killed God. Okay. So now what you are seeing is that the natural theology window has broken. You cannot anymore use the natural theology window to understand how a particular organelle or an organ has evolved. You have to use the evolutionary window. Now, if you teach your student about the Sankhya Darshana, then the student will be able to understand that this evolution, this particular framework of evolution can be used to understand the origin question. You can apply the Sankhya Darshana to understand evolution. Ask the proper questions about evolution. How the first form of life came up. What was the disequilibrium? The equilibrium was broken. And kind of a stochastic processes, kind of different processes started happening inside the organism. So, where I have to look into this? I can use Sankhya Darshana as a tool for gaining knowledge. That is, I am using Sankhya Darshana as an epistemological tool. I can also use Sankhya, I can go and beyond Sankhya Darshana, and I can go to Advaita Vedanta, then I can see all as the manifestation of one. How the one becomes the many, that is the question that I have to ask. Not how this was designed. How the one becomes the many. What is the process that is happening? So, you change the question. This is the epistemological aspect of the window. Then there is another aspect. Your student may not always be, he or she is not going to be a scientist. He may become or she may become an artist. The artist, when he or she understands the beauty of nature, the dynamics of nature, he or she can become a better artist. Again, you can now use the same window to understand nature as a dynamic process. A dynamic evolutionary process where the Prakriti and Purusha are involved in a kind of a dance. Right? And then this becomes a window for ontology, reality. How do you understand this particular reality and how do we apply it to my domain of art, my domain of philosophy? I can update my philosophy. I can enrich my art through this particular window. So, you have to be very careful. You have to decide where I can do the IKS intervention in my teaching beyond the IKS module. When you start doing this, what will happen is that you will be able to give inputs to change the IKS module also. You will be able to make the IKS module adapt and update according to the changes in science. And you can use the IKS intervention to make your student more and more accepting the beauties of science, becoming more receptive to the beauties of science. There was a great scientist in Kerala. His name was George Sudarshan. You all would be knowing him. He was a physicist as well as he was a great Vedantin. And he was once asked, what is that you derive from science? And then he said that when you are actually making a discovery, this is a very important thing. When you are actually making a discovery, you at that particular point of discovery, what happens is I become completely, the I in me becomes completely erased. The discovery, the process of discovery, the discoverer, they all become together one. That feeling of non-duality, that feeling of Advaita, achieving that makes my entire scientific journey a sadhana. So, here, George Sudarshan pointed out an important lacunae that we have in framing our science policies right from the time we attained freedom. Have you ever wondered why we have not been able to generate a lot of scientists who ask the fundamental questions and give the answers? Our scientists are exceptions to the system. You have a George Sudarshan. He's an exception to the system. Why we are not having such scientists? As you see in the West, if you just go to any bookshop and look at the people who have written about science, popular science, you will have a Carl Sagan. You will have an Isaac Asimov. You won't see a lot of Indian names. You will have V.S. Ramachandran, of course, but V.S. Ramachandran is now an American citizen, again an exception to the system. You won't have many Indian names. The reason is because our science curriculum does not make our students to ask the fundamental questions. If you have to ask the fundamental questions, you have to have your roots very strongly based in your knowledge system. What you are doing actually is that we created a concept called scientific temper. So this scientific temper is something that you have to learn from outside. We were told, you have to develop a scientific temper. Now look at what George Sudarshan said. George Sudarshan said that you have to have the joy of discovery that is rooted in Advaita, in non-duality. So here he is talking about the psychology of doing science. Scientific temper is different and psychology of doing science is different. Psychology of doing science is something holistic. The IKS syllabus should be tuned in such a way that the student learns from it as to how to do science, how to ask the fundamental questions, how to move from there onward into the stage of exploration. That is what we have to do. That is what we have to make the student do. Now, the third aspect that I want to stress is, I told about the two fallacies, but there is a third aspect. And this third aspect is what is actually fueling these two. We have been given an inferiority complex. That inferiority complex is that we don't understand the method of science. That is the inferiority complex. The method of science evolved entirely in the West. That is what we have been told. Okay, what is the method of science? The method of science is that you make observations and based on that observations you do calculations and you create a model. That will be approximating the reality. That is the scientific model. Who developed this scientific model, this method of science? If you ask any historian of science, he will tell you, she will tell you that it is Francis Bacon. So Francis Bacon created this. And all the developments in Western scientific tradition, they start from Francis Bacon's method. Recently, a famous Indian scientist died. His name was Jayant Vishnu Narlikar. So Narlikar was once asked, you come in the tradition of Aryabhatta, what do you think about your Indian tradition? Then Narlikar stopped. Narlikar said, I don't come in the tradition of Aryabhatta. Aryabhatta was my ancestor, of course, and he made some great discoveries, true. But I don't come in the tradition of Aryabhatta. I come in the tradition of Francis Bacon and Galileo and Newton and others. That is the scientific tradition, he told. Then he went on. He told that Indians lack the concept of observation and calculating things. This observation-based science is not there in India at all. And he gave some examples also. Remember, Narlikar was also a great Sanskrit scholar. Okay. So, this particular statement of Narlikar, it almost became an axiom for teaching science in India, the philosophy of science in India. So, they used to say that Indians lack the capacity to observation. So, they had these insights and they had these intuitive feelings, and because of that they wrote. People will easily accept this, because when our ancient mathematicians write or whenever ancient scientists wrote, they wrote in the form of sutras. And so they were all insights that came, and they never developed any kind of an experimental model, they never developed a kind of an observational model. That is what was told. So recently, Indian Institute of Science, they published a very important book. It is called Computation Meme. Computation Meme. It is a collection of articles, papers, not articles, papers, on the tradition of Indian science. So what is this computation meme? You all know what is a meme, right? What is a meme? Meme is not the thing that you get in the internet. That is one form of meme. Meme was a name that the term was coined by Richard Dawkins, an evolutionary biologist. So what he meant by meme was that it is an idea, any form of idea. It may be a song tune. It may be the picture that you are getting in your WhatsApp. It may be a book that you are reading. It may be an idea that you have got. So that is a meme. That meme will not sit idle in your brain. It will be going on to other people, right? Like a virus or like a gene. The gene gets transmitted vertically. The meme would be transmitted horizontally. So you will be teaching to your colleague. You will be humming a particular song. That particular humming may look very good, and then another person may hear that and he starts or she starts humming. So the meme has spread. There is a particular gesture that your teacher does when he or she is teaching. You watch that and you start doing that. Now the meme has spread. So this is meme. So he said there is a computation meme, and this computation meme is there in Indian civilization. Then he goes on. This particular book was compiled by a scientist called Kanchi Gopinath. And there are a lot of people who have contributed. One of the contributors you may be meeting today evening. So this particular thing, what he told was, there is a tradition in India, and this is the most dominant tradition in India. It is called Drig Ganita Aikya. That is, observation and calculation or mathematics would be always go together. What is the difference? In Greek tradition, you have an axiom. You have to prove that axiom. So, in Greek tradition, the science developed in an axiomatic way. If you love the axiom so much, like Pythagoras did, then you will not allow the concept of irrational numbers. Because the numbers cannot be irrational. Everything has to be a perfect ratio. So when the irrational number was first discovered in Greek, the person who discovered it was killed. Because they won't accept the irrational numbers. In India, that is not the case. In the case of India, what happened was, we had calculations based on observations. In other words, we had an algorithmic approach to science. The Greek approach was axiomatic. The Hindu approach or the Indian approach was algorithmic. And this made all the differences. And this book shows a lot of Indian mathematicians who actually emphasize this, including the Kerala mathematician, Neelakandan Somayaji. So all this tradition is given with the Sanskrit verses. And then he points out, could have been because of this Indian influence that Francis Bacon was making the statement, the observation should be there. Before Francis Bacon, observation was not part of the Greek tradition or the Christian tradition or the Western tradition. The Western tradition was not based on observation till Francis Bacon. It was based on axioms. A theory has to be there. The theory has to be supported. The theory will dictate what you should discover, what you should not discover. So if you are discovering a heliocentric data, you are presenting that data, and if the theory says heliocentric theory is not, centric universe is not allowed, then heliocentric universe is not allowed. Heliocentric solar system is not allowed. If you think that this is something that only belongs to the time of Galileo, you have to think again. When communism came, do you remember how many of you have seen these famous Russian cost-effective popular science books? You have all seen, because we all would have seen. We grew up in Nagaru in India. So we have always seen this mere publishers, Science for Everyone books. Okay. For us, because if you are going to buy a foreign book, it is very costly. If you are going to get an American book, it is very costly, unless otherwise it is a pirated edition. Now you can get everything in LibGen or you can get everything in internet. But at that time, the easiest popular science books and good books we got from Soviet Union books. There would be book exhibitions in the schools and all. Okay. So here, they used science for theory. Again, this is another one important thing that we have to avoid when we are teaching IKS. Fortunately, as I said, IKS is a window. It is not a system that is going to constrain you. If your worldview is not limited to Sankhya, you can move to Advaita, you can move to Vedanta, you can move to Vaiseshika. So your worldview, you can shift actually depending upon what you are getting. The ontology and epistemology is pluralistic here. Okay. This is something that you have to convey to your students, that you can approach a particular problem in multiple ways. That is the Indian knowledge system. Okay. Now coming back to this. So, in 1917, the October Revolution happened. And then there was a big problem. The biologists were kind of skeptical about this new regime, how they are going to treat us. So Lenin was kind of accommodative and he said, okay, we won't be touching your work, you continue with your work. But at the same time, he had also said that it should toe the line of dialectical materialism. He had hinted at it. You should toe the line of dialectical materialism. If you are not doing that, we won't be liking it. But then in 1924, Lenin died, Stalin came. Then something very interesting happened. At the time when Stalin came to power, there was a big controversy that was going on among biologists. They had discovered the work of Grigory Mendel. Mendel was the one who discovered genetics. Then there was another one school called Lamarckian school. So Lamarckian school said that the acquired characters are transmitted. What you acquire in this particular life, right? For example, you are very efficient in writing. You are learning a particular cursive way of writing. Then your child will naturally have the cursive way of writing. That is what Lamarck said. So the giraffes, their neck length increased because every giraffe was trying. So that added the neck length to its next giraffe. That way the giraffe's neck became long. Now this means that environment decides inheritance. What Mendelian genetics said was the innate factors decide inheritance. So this debate was going on among scientists throughout the world. Throughout the world, the debate was going on. Of course, the genetics were winning the debate. Very clearly, the genes were real. They were innate factors, and the genes do not get much influence. The genes do not get, mostly they do not get influence, except for the epigenetic influence. They do not get influenced by the circumstances, right? Because we have in India for millennia together, we have women with their earlobes pierced. But we never see a woman child born, a girl born with the earlobe pierced. Right? So the inherited characters, they do not get passed on. There are innate factors. These innate factors decide your character. That is the genetic stand. And it was getting successful. Everywhere it was getting successful because the experiments showed it. The experiments proved it. In Soviet Union, the ideology decides. So they said genetics is bourgeois science. Okay? Genetics is bourgeois science. So it should not be taught. They started capturing the genetics, people who taught genetics, put them into jail. They were harassed. The lucky ones died easily. The unlucky ones, they had to suffer like anything. That was, you have heard about Catholic Inquisition. But Catholic Inquisition was absolutely nothing when compared to this Marxist Inquisition. They killed hundreds of scientists. Not only in biology. Quantum physics was also considered as not fit to be taught because it was against dialectical materialism. Okay. So what you are seeing here is actually a particular disease that comes from the Greeks. That the theory has to decide the reality. The theory should not get adapted to reality. The theory is paramount importance. The theory has the great importance here. So, this is a fallacy that we have to avoid. This is a fallacy we have to avoid. Fortunately, in Indian knowledge system, this fallacy doesn't come because, as I said, it is pluralistic. There is epistemological pluralism, there is metaphysical pluralism, there is ontological pluralism. You have the 6 darshanas. I will ask the teachers, I will ask the educators, the lecturers here to think about it. Take any problem in your domain. Then apply these 6 darshanas to that particular problem. Find out what kind of different questions you come up with. What kind of different questions you come up with. It's very important. Okay. Very, very important. Because when your approach changes, you can make leaps. Not just in pure science. Science can be, usually they tell that science can be divided into two things. One is as lucifera, science giving light. Another one is as fructifera, science giving fruits. That is technology. Okay. In both, we always used to think that technology is something that is applied, that's all. But technology has embedded values. Every technology has embedded value. So the technology will decide who is going to be the end user. The technology will decide who is going to become profitable, Who is going to get profits because of this particular technology? Who is going to lose out because of this particular technology? Okay. In designing technology also, the questions that you ask, the framework that you make, they are very important. For example, have you heard about the AI winter? AI winter is a very interesting thing. Okay. When there was this great scientist, mathematician, John von Neumann, and he was the one who designed this basic computer concept that you have got a central processing unit, you have got an input, you have got the output, right? That is what we all teach our students also. There is input, there is central processing unit, getting processed, output. And in our mind, what is that we relate this to? To our sense organs, our brain, and the output, right? So this was what was told. And when people started thinking about it, they thought that we can do AI by studying the brain, the way in which the circuits are present, the neuronal circuits are present, and based on that you can create circuits and you can make AI intelligence. There was a lot of enthusiasm initially. Soon the enthusiasm died out because they couldn't achieve anything there much. Then suddenly there was a change. This is called the AI winter. Initially there was great enthusiasm, then it all died out. You will remember, you will be talking about AI for a long time. 80s you would have talked about AI, 90s you would have talked about AI. But it is now that AI is making just leaps and bounds. The reason was because there was a change in the approach. They said that intelligence is not about what is inside the central processing unit. It is about how the system learns. Learning is related to intelligence. They started making machines that is based on the processes of learning rather than the components inside. So once that started happening, when the learning model was applied to AI, then AI started just like that, it started flourishing and it started moving. The point again is the framework that you are bringing to the system, the question. And to get that question, you have the most powerful tool in the form of IKS. It is not about telling the student we arrived there first. It is not about telling the student we knew everything already. It is about telling the student we are very relevant. We are having a gift to give to the people of the world. And that gift is this pluralism of asking questions, pluralism of looking at things. So, for that, you have to equip yourselves. How do you equip yourselves? As I said earlier, I would request you to read popular science books that are written. A very important book I would suggest to you is now 50 years old. Exactly, this year is its 50th year. When it was published for at least some 20 years, even now, it is very famous. It is called Tao of Physics. So this book will give you an idea of how the Eastern traditions and the worldview that is revealed by the modern science have parallels. It will give you the very important basic aspect. Then you read the other books by the same author. He is even now active. And he has framed a beautiful conceptual framework. He is actually taking courses on this. The second book is Turning Point. So this book is also important, and I think this should be made almost compulsory material for the teachers. You should learn them. And you will find that this particular book, Turning Point, talks about paradigm shift. So how this paradigm shift is happening? The very way in which we view things is happening. Okay. Because when the Newtonian physics was at its high, nobody talked about ecology. But when the quantum physics, the new physics started emerging, then ecology becomes important. The reason is because the quantum mechanics is about interconnections. Albert Einstein called them spooky actions in a distance. Okay. There is a recent paper in Nature. If you are interested, you should, Vaira et al., that paper is. If you are interested, you see it. You will find that it talks about the entire universe being super deterministic. That means right now I am talking to you. This is already determined when the first Big Bang happened. Okay, so these are all possibilities that are present for you to do. And you read Turning Point, you will understand how the science affects the other value systems, which is important because the Indian knowledge system is in itself a paradigm. So how you are using this to affect the study of new physics and teaching the students the new physics, that will be very interesting. Okay, a famous educationist, Richard Feynman, he said that if you are learning quantum mechanics and you are not surprised, you are not kind of confused, you are thrilled by it, then you haven't understood it. Okay, so it talks about a cat being simultaneously alive and dead, a particle that is completely unrelated to another particle except at the beginning, changing that particular particle. It is a very, very weird world that the quantum mechanics is depicting. That is a very good place where you can teach IKS. You can tell them about the interconnected universe. You can tell them about Maya. You can tell them about the different ways of reality. So, the first thing that you have to do is you have to equip yourselves. You have to equip yourselves very seriously. Because right now we are undergoing a civilizational renaissance. And IKS plays a very important role in that. If we are making IKS another one moral science story, we are losing the civilizational battle in the world. And losing this civilizational battle means we are robbing the world of the treasures that we have to give them. Remember that. India lives not for herself. India lives for the entire humanity. If we are not giving the treasures that we have to the world, then we are betraying the entire planet. And that treasures can be given through IKS. When you teach IKS, you have this responsibility with you. And I request you to take this responsibility seriously and work hard to create your own modules, every individual modules. For each and every teacher can create his or her own individual modules and give it to the student. Thank you very much.